Hello and welcome to the AMIS class. Today we are going to read the question which says find the derivative of sine x using first principle. So let's start. Solution. First we have to let y equals to sine x. So that will be finding the derivative of y in terms of x. That's like a solution. So this is our equation. Now we'll add the y to y and the x to x. That's differentiation of y to y and differentiation of x to x. If we had used u as a letter here, it would have been du, and if you had used something like a as the variable here, it would have been dA. That's if we are finding the derivation of u to in terms of a. So next we are going to subtract this equation now from this one, the one that we added the y and the x. So from here we have minus y, and this will be sine x plus dx minus sine x. Yes, so from here we can simplify this and it will remain dy, but here we cannot simplify this one because of this here. Y minus y will give us 0, which will be left with dy, and this, let's bring it back, x plus dx minus sine x. We have to express this to make it easy for us to simplify, so we check whether we can simplify it or not. So if we have to express it, we are going to use the compound angle addition formula for sine, which is if you have sine a plus b is same thing as sine a times cos b plus cos a times sine b. So this is what we are going to use to express this. So here now x is our a and dx is our b, so let's impute it. Dy equals to sine x times cos dx plus cos x times sine dx minus sine x. This equation I'm bringing it back. So let's put bracket to show that we're expressing this. I'm going to rewrite this one without the brackets now. Plus cos x times sine dx minus sine x. Here we can simplify by bringing out the common factor that is here, and the common factor is between this and this, is in between this and this. Here has sine x and here also have sine x, but there's no common factor here, so let's go and bring out the common factor. So the common factor, as we said, is sine x. Cos dx minus sine x plus cos x minus sine dx. I'm bringing the two of them that have the same common factor. So bringing out the factor, we'll have sine x brackets sine x divided by this will give us cos dx, and sine x divided by this will give us minus 1 plus cos x times sine dx. So now the next thing we are going to do is to divide both sides by dx. I want to separate this fraction into two. You know it has plus sign, so it's possible for us to separate it and separate the side to be easy for us to simplify. So this is it being separated. Our next thing we are going to do now is to, let's bring out this, okay, let's limit the x to 0. So limiting the x to 0 give us this sine x cos dx minus 1 x plus x. Now let's give each of them their limitation. Sine x bracket cos dx minus 1 divided by dx plus limiting the x tending to 0 cos x times sine dx divided by dx. So now, as it is here, sine x is like a constant and cos x is like a constant. So the ones that have the x in them is something like the variable. So we are going to bring this out. So y divided by dx equals to sine x limiting the x to 0 cos dx minus 1 divided by dx plus cos x limiting the x to 0 sine dx divided by dx. So from here now we have it as dy dx equals to sine x. If we limit this, it will be the dx here will turn to 0, so it will be cos 0 minus 1 divided by 0 plus cos x, and limiting this will give us 1. Limiting this whole expression here will give us 1. Now we are going to be having dy dx equals to sine x. As we all know, cos 0 is 1 minus 1 divided by 0 plus cos x times 1, cos x times 1 is what? Cos x. So from this we have it as dy divided by dx. dy divided by dx equals to sine x, 1 minus 1, 0. 0 divided by 0 give us 0 times 0 plus cos x. From here, sine x times 0 is 0 plus cos x. That will now give us our final answer as cos x. Therefore, we have it that the derivative of sine x is cos x. So we got our answer as cos x. Hope this was understandable. So see you in my next video. Bye. Please don't forget to like, subscribe and share.